All right, let's jump right into this explainer. We're looking at a massive, incredibly complex technological shift that is completely reshaping global naval power as we speak. Because historically, whoever controls the oceans controls global trade and security. We are witnessing a monumental paradigm shift in how aircraft carriers actually operate, and it's fundamentally altering the maritime balance between the United States and China. What's happening is an absolute race to master a brand new technology that defines the very future of naval aviation. Think about it for a second. How do you actually launch a 3010 fighter jet off a runway that's just a tiny fraction of the length of a commercial airport while bobbing up and down in the middle of the ocean? It's an engineering nightmare. For decades, navies have relied on one singular, highly guarded technology to solve this problem: the steam catapult. But the contrast between that legacy brute force and the precision of the future is stark. Steam catapults are incredibly violent. They jolt an aircraft with up to 6 Gs of force right at the start of the launch. This severely limits the ability to launch lightweight drones, which could literally shatter under all that stress. Plus, inhaling all that steam degrades the aircraft's engines over time. The future is EMALS, the Electromagnetic Aircraft Launch System. It uses extremely precise, tailored pulses of electric power. You can dial it in perfectly for a heavy fighter jet or a super lightweight unmanned system. The physical advantages of making this switch are honestly mind-blowing. A traditional steam system is massive, taking up about 1,100 cubic meters and weighing over 500 tons. EMALS slims that down to just 400 cubic meters and 300 tons. While steam guzzles 600 tons of steam per launch, EMALS uses 60 to 120 megajoules of electricity. By moving to electric catapults, navies reclaim huge amounts of internal ship space and save hundreds of tons of weight. It completely changes the game for naval architects. But as you might guess, adopting a brand new paradigm is painfully difficult. We can see this detailed very clearly in the Department of Defense testing reports for the newest American supercarrier, the Gerald R. The U.S. Navy is the absolute pioneer of this technology, but they are currently facing the grueling reality of innovating EMALS on a massive, real-world scale. To really wrap our heads around the U.S. Navy's growing pains here, we need to talk about a highly specific military metric called MCBOMF. That stands for Mean Cycles Between Operational Mission Failures. Put simply, it's just the number of times you can successfully shoot a jet off the deck or catch one coming back before the system suffers a critical breakdown. And here is where things get rough. The target requirement for this new electric catapult was 4,166 launches between failures. That's the baseline needed for reliable combat operations. But the actual performance during early testing? Just 272 launches between failures. It's a staggering gap between the theoretical prowess of EMALS and the incredibly tough reality of operating it at sea. And catching the planes? Just as complex. The advanced arresting gear, the electric system that physically catches those landing jets, managed an average of just 41 recoveries between failures during early testing. 41! That falls vastly short of its 16,500 cycle requirement. So, why is this happening? Well, the defense reports highlight a cascading maintenance nightmare. The ship's advanced electrical systems are incredibly interconnected. Because of shared electrical inverters, the crew can't just flip a switch to easily isolate a broken component. In fact, simply powering down the EMALS motor safely so you can fix it takes an hour and a half. That essentially cripples active flight operations, making mid-mission repairs nearly impossible. Now, let's shift our focus to the other side of the globe. Because while America has been battling to perfect the electric carrier, the Chinese PLA Navy has been executing an entirely different, incredibly rapid strategic shift of their own. To appreciate how far China has come, you have to realize where they started. For decades, the prevailing doctrine in Beijing was basically the land outweighs the sea. Historically, China viewed itself almost entirely as a continental power. In fact, Mao Zedong's focus on land-based protracted war meant aircraft carriers were completely dismissed as just extravagant symbols. But the 1995 Taiwan Strait crisis changed everything. During that event, the U.S. deployed 2 aircraft carriers, which completely exposed the absolute limits of the PLA's naval power. Witnessing that immense American projection firsthand caused a massive doctrinal shift in Beijing. Suddenly, they began to view their surrounding oceans not just as water, but as blue soil, an indivisible extension of their homeland that required a world-class maritime force, and specifically carriers, to protect. But there was a major catch. China completely lacked the industrial base and resources to build an aircraft carrier from scratch. So Beijing took a really unconventional and honestly kind of funny shortcut to get the ball rolling. They actually used a businessman to buy a rusting, unfinished Soviet hull, the Varyag, from Ukraine for just $20 million in 1998. The cover story? No joke, they claimed they were going to turn it into a floating casino. But over the next 25 years, that casino hull was studied, reverse-engineered, and eventually commissioned as their first carrier, the Liaoning, in 2012. By 2019, they built their own, the Shandong. And remarkably, looking ahead to 2025, they're set to launch aircraft off the Fujian, a fully indigenous supercarrier equipped with EMALS. But getting from the Liaoning to the Fujian wasn't easy. Those first two carriers utilized a curved ski jump ramp at the front of the ship, and that severely limits the takeoff weight of the jets. It forces pilots into a super frustrating compromise. You either launch with a full tank of gas, or you launch with a full load of heavy weapons. You just can't have both. A catapult, on the other hand, allows a jet to launch fully loaded, maximizing its actual combat effectiveness. So how did China learn carrier operations before they could build a catapult? Through some incredibly scrappy, relentless workarounds. They couldn't buy carrier jets, so they bought a prototype from Ukraine and reverse-engineered it into their J-15 fighter. They had no way to train pilots at sea, so they partnered with Brazil and trained on a retired Brazilian carrier. And most surprisingly, when the US and Russia completely refused to sell them the arresting wires needed to catch planes, they discovered that a local domestic industrial rigging company in China, who sold steel cables to the West, was already making the exact wire they needed. But as China set out to build their third carrier, the Fujian, they hit a critical crossroads. They knew the ski jump was just too limiting. But traditional steam catapults were a closely guarded, intensely complex American monopoly. You see, steam requires ultra-precision machine tools, insane metallurgy, and exacting fabrication processes. Mastering it takes decades, and the US and its allies completely locked that technology down. So China made a seriously bold, ambitious decision. They bypassed steam entirely. They decided to skip those decades of trial and error and leapfrog directly into the electric catapult age. The technological breakthrough that actually made this wild leap possible came from a team led by Chinese Admiral Ma Wei-mime. They championed a novel power distribution standard known as medium voltage direct current, or MVDC. This is a huge deal because it eliminates the need for massive heavy transformers on the ship. Instead, it efficiently feeds stable, massive pulses of energy directly to the high-demand electromagnetic catapults and potentially even future weapons like railguns. So that brings us to an absolutely fascinating global reality. We have two navies taking radically different paths to arrive at the exact same technological frontier. On one hand, you have America, the established heavyweight, fighting through the grueling, meticulous reality of innovating EMALS on a massive scale, working through those interconnected system failures. And on the other, China has scrappily, relentlessly reverse-engineered and accelerated its way from a floating casino to that exact same electric frontier. Which leaves us with one final, absolutely vital question to ponder. As these two distinct navies deploy the exact same electric launch technology, the era of exclusive maritime dominance is shifting. What happens to the balance of power in the Indo-Pacific, and really the world, when the long-held monopoly on advanced supercarriers finally disappears? Thanks for exploring this explainer with us, and we'll catch you next time.